So what's next is chapter 6, and this is all about percents. And so the first section mostly is about moving back and forth between percents and decimals and fractions and so on. And so the first thing I want to say has to do with the definite meaning of percent. So when you have something that looks like this, 5%, I'm going to write it like this. Now, we've had problems where we saw an example where they use the word of. So for instance, let me just come up here a little bit. So when we had half of 10, the word of mathematically meant multiply. And so what you would do is interpret it like this. And so then you would go ahead and solve the problem. But with 5%, literally per means divide. So when you see the word per between two numbers, and this is a number, and this really is also a number, the cent really is 100. So the literal translation of 5% is 5 divided by 100. Now there's two ways to write it. And so the two ways, one is the fraction way. And so that would be 5 divided by 100. And if that's the case, then we would probably reduce it. But the original answer is 5 over 100. 5 into 5, 1, and into 120. But the other way to do 5% is when you have 5 divided by 100, let's consider writing it as a decimal. Now, sometimes decimals are easier. Sometimes, once in a while, fractions are easy, believe it or not. And so what we started to talk about is when you have a number and it's divided by 10, 100, 1,000, something like that, there's an easy way to do the computation without making a big deal of it. And the result is the 5 initially has the decimal here. When you divide by 100, the decimal shifts, and it shifts to make the number smaller because you're dividing. And so it would shift 1, 2 decimal places. So 5 divided by 100, which was 5%, is 0.05. There. And of course, there's the front 0. I saved the front 0 for last because I don't want to have some confusion about where the things go. I moved it from here, 1, 2, 0.05, and then I did this extra 0, which is in the front. I call it the decoration 0, but nobody else does.
In the book, they call it the complimentary 0.
Okay, how cute.
Yeah,
it kind of
confuses me.
Because frankly, depending on when you're in school, and because I was in school a lot before most of you, this was acceptable. But then around 1970, 80, they started bringing in this 0. And so complimentary or decoration, I don't care what it is, it's now considered standard. And I keep saying this, in hospitals in certain settings, it's required. And so it's best if you start putting that in. But anyway, this is what I wanted you to see. 5% translates into 5 divided by 100. The fraction way, 5 over 100, reduce, or the decimal way, slide the 2, the decimal point, which was originally here, 2 to the left. So this means that, oh, where is that person? Somebody's trying to get in. I'm gonna have to go out of this for a second. Now I have to go back. Okay. So one of the things that they had in the explanation of all this was this little table, fraction, decimal, percent. Okay, so I saw that in the textbook, and it would be in the reading. And so what we need to do is get the ability to go back and forth. So if you had, I'm going to do one that you probably should guess pretty easily. If the fraction was 1/2, you can divide this out, but the decimal is 0.5. Right? And so that one you probably should know by heart. The percent, what we're going to do when we want to go from a decimal to a percent, we're going to take the decimal point and move it 2 places to the right. So this decimal point here goes 1, 2. This is 50%. And I hope you know those 3, that 1/2 of something is 0.5, and that's 50%. But if you know one of these, like this one, then it makes it easier for you to do others. So I'm going to start at this end, and I'm going to start with 25%. Now, 25% is actually, as a decimal, 0.25. And so what happens when you go from here, from percent to decimal, the decimal has to shift 2 to the left. So that would mean 0.25. So it was here to start with at the back. When it went to a decimal, it's 1, 2. And so that's what it looks like. Oh, good, I can admit that. Okay. Now, when you need to go to a fraction, you might be able to go from here. You could easily go from here. This is 25 hundredths, tenths, hundredths, and 25 hundredths in its simplest form is 1/4. Is that okay? A quarter is 1/4. And I meant money. A quarter of a dollar is 1/4 of a dollar. Are these, any question about these two? I'm not hearing anything. Okay. So what they're going to be doing in this very first section is say, okay, let's see what we can do now. So they'll do just a piece of this table. So one example, 20%, and they want it as a fraction. Okay. So 20% as a fraction. Remember, it's 20 per divided by 100. So that would be a fraction. And that would be a very good start to this particular exercise. The 2 zeros at the end can go like that. So the problem is now 2 divided by 10. And then if you divide each by 2, it would be 1/5. They used to make people memorize all of this. Well, 1/5 is 20%, which is 0.20. And they, I don't know, there would be a half a dozen maybe that they'd ask you to memorize. So let me try something a little bit differently, a little bit different. 48%. The exercise is still take it to a fraction. Easy. 48 divided by 100. And then, but when it's a fraction, the assumption is you will simplify it to lowest terms without anybody saying it, although most of the time they will. So you could divide by 2, but if you look carefully, you could actually divide it by 4 and be done sooner, because 4 goes into 4, once, and 4 goes into 8 twice. And 4 goes into 100 25 times. 4 goes into 10 twice, 2 left over. 4 goes into 25 times. So this is the reduced version. You then look to see, will this reduce further? Now you could have divided by 2 and divided by 2 again, but it was fairly obvious 4 would work to me, so I just did it. Because this 25 is 5 times 5, the only way this would reduce is if there was a factor of 5 here. There's not. So this one is done. Okay. So next one, change the percent. So the next set of problems is a percent to a decimal. Okay. So let's do this one. 23%. Now you might refer back to this. When you had the percent and you needed to go to the decimal, literally it's to the left from this table, and it's always 2 places, 2 decimal places. So that's the instruction, 2 to the left. And so what I need to do is take this off. There's my decimal, 1, 2. So my answer is 0.23. I put in my complementary 0. And there's your answer. Okay. Now let's do 7%. The instruction was to make it a decimal. And so the percent comes off. The decimal point is here initially. You've got to go 2 places, which means you've got to add that 0. So don't forget it. You had to go 2 places. And here's your complementary 0. Let me try something a little bit weird. 0.6%. Now, just because this was a decimal, this is really a percent with a decimal in it. And so what you have to do is the same exact instruction. The percent comes off. This goes back 2 places. So it's now 0.006. The decimal's now here. And then the front 0. Okay. So that's, let me just try one more. 7.25%. And what I want is a decimal. Whoops, there. Just because this looks a little bit different than the others, doesn't matter. The percent comes off, the decimal goes back 2 places to the left. So I'm getting 0.0725. You don't throw anything away. And then at the very end, add that extra 0 at the front. So that's what we need to do. And if you say, I can't remember if it's left or right, well, then you go back to a problem you know for a fact. When you had 25%, it turned out to be 0.25. So it really, the instructions were to go to the left and go 2 decimal places. And so there we were. Once you know which way to go, you're all set. Or you might, in this particular problem, thought of 7%. After a while, you get to the point where you know that is what 7% looks like. And so then you knew, okay, what I had to do was go left, and I had to go 2, because it's always by 100, so you go 2. Now, let's try the next batch. So let's see, I want a decimal to a percent. All right, now we're going to do the reverse. Decimal to percent. So 0.54 is a decimal. I want to turn it into a percent. And if you remember from the table or from any of the examples we've looked at, when you had a decimal and you're going to a percent, you're having to go to the right, going toward the percent. And so it's 2 places to the right. 1, 2, there you are, 54%. Now, why all the fuss about going back and forth between fractions and decimals and percents? And if I can find the right page, I'll tell you. Here. Very first page. If I'm going to do a computation, 5% of something, I can't use the 5. I've got to use either the fraction or the decimal. So if I'm going to do a computation, it requires to get it out of percent into one or the other. And so the reason we have both, again, is because sometimes one is much easier than the other. Most of the time it's decimals, but not always. And so we have to have 2 ways to do it. But in the end, the question may be, well, do the computation, now what's the percent? So what might happen is you did the computation and you get this number. But then they said, well, for the final answer, I want you to give it to me as a percent. And so you've got to move this over and say 54% to have it be right. So this is the reason we've got to go back and forth between these 3 items. And so let me try decimal to percent. So again, this is decimal. I'm going to abbreviate this time because I'm tired of it. Okay. 0.8. Remember, when you're going toward the percent, it's 2 places to the right from the table. So that would be 1, 2. So the answer is 80%. 2.34. No percent there, but the result and the process is the same. So it's 1, 2, 234%. And you can be over 100. You've seen that with prices, they go over, they're more than 100% higher. So that's where we're at. Okay. That's a decimal. It wants to be a percent. And so regardless, it's 2 places to the right. So it would be 31.5%. You don't throw away those last parts of the number, just copy them in. And the decimal belongs there. And so it's 31.5. Okay. So when this seems overwhelming, like I can't keep this straight, this is how you keep it straight. You work with something you know, and then you can keep it straight. So let's take the next batch. We want to change, let's see, percents to fractions. Okay, here's the first one, 4%. So when you know you're going to a fraction, let's make a fraction. And so 4% is 4 divided by 100. Let's reduce it by 4. 4 into 4, 1, and into 100. 4 into 100 is 25. Okay. Now what are we going to do? This is a decimal inside a percent. If you had to give this a category, it is a percent. And we have to turn it into a fraction. I probably should have picked an easier one to show. But one way we could do it is to start, turn this into something that looks more like a fraction. And so the first thing I could do would be 26.5, but that's still a percent. It's just 0.5 and 1/2 are the same thing. Now, let's see what else I could do. I could make this a fraction because this is a mixed number. So 2 times 26 is what, 52? So 52 plus 1 is 53 over 2%. Well, I started with 26.5, I made it 26.5, and then I did this. Now, if you remember, percent means divided by 100. So we've done this before. We know percent means dividing by 100. We're trying to get it into a fraction. And so what we need to do is rely back on whatever we did previously. Remember what needs to happen. This number has to invert. This has to go to multiply, and the first number does not change. 53 over 2, multiply 1 over 100. Fortunately, that doesn't look too bad. 53 is prime. So 53 times 1 would be 53. And 2 times 100 would be 200. That's not going to reduce, and I'm happy to say it doesn't reduce, so we're done. Not that we didn't have to do a bit of work here, but this is, the decimal had to be a percent, or had to be a fraction. The better form was the improper fraction, 53 over 2. And then finally, we figured out how to remove the percent symbol by its what it means, dividing by 100, and then we had to go from there. That, of course, is probably one of the least favorite, but that's one of them. What I wanted to do was do one more. Okay. We have a fraction that wants to go to a percent. And sometimes, let me go back to my page because this is my reference point. Sometimes when I have a fraction and I want to go to a percent, the easiest way is to make it a decimal and then make it a percent. In other words, follow the path. And so that's what I'm going to do. To make 4/5 a decimal, you need to divide. And just because you want to put 4 on the outside, that's not what it's saying. 4 divided by 5 means that 5 is on the outside. 5 is what you're dividing by, and you have to have 4 here. So this was one little trick I showed you with a fraction to turn it into a division problem straight away so that you wouldn't twist these two. So this is really 5 divided into 4. Well, it's not going anywhere unless you add some zeros. This decimal comes up, and fortunately, 5 goes into 40 8 times. No remainder, so we have a result. So the 4/5, and you may have realized it, is 0.8. Are we done? No, they wanted a percent. And so to make it a percent, you say, what am I supposed to do? I've got a decimal. I want to go to a percent. It's 2 to the right. So I can do that. 1, 2, 80%. And if you have a sense that you've made a terrible mistake and it's not right, let's see if this makes any sense. let's do it with a test. If there were 5 questions and you had 4 correct, would you get a fairly good grade? 4 out of 5, would you? Not bad. Could be better, but not bad, right? Does 80% sound like the appropriate grade for you to be given?
Yeah, that's like a B almost.
Does it seem about like that would be about right? 80%?
Sure does.
I think it sounds okay. Yeah. And so that makes sense. If you had only 1 correct out of 5 total, it turns out that when you divide this out, it's 0.20. And when you turn it to percent, it's 20%. Does that sound about right for getting 1 out of 5? Most people are familiar with percentages on their test. So if that clicks, then see, that's one way to judge. Does that seem about right? It actually, that is equivalent. This becomes 0.20, becomes 20%. And after we do this a while, you get to the point where you know a few by heart. You know what I'm saying? They actually, have you memorized. So let me see if I can't find just a couple of others to try. 9 over 25, and we want to go make it a percent. That's okay. Now I've got 2 ways, because remember I've told you I have this lazy streak, and when I see a good opportunity, I take it. I can only take it because I know what will work all the time and what you won't. But first of all, I'm going to show you a standard way to do it before you see the cleverness of how to get quickly to there. The first thing I would do is I would take it to a decimal, like I did before. So 9 divided by 25 means that 25 is on the outside and the 9 is on the inside. So if you don't like that mess, I'm going to put 25 into 9. It won't go, so I need to add a couple of zeros. 25 doesn't go into 9, but it will go into 90 if you think of money. There would be 3/4, which is 75 cents. When I subtract, I get 15, and I bring down the 0. And if you think of money again, a quarter into 150, there would be 6 of them, 4 and 2 more. 6 times 25 happens to be 150. There's no remainder here. So that's a really good answer. That's an exact answer. So what I have is 9 over 25. As a decimal was 0.36. Here's my 0. From this point, it's really easy to get to here because it's only a decimal shift. And so decimal point 36 or 36 hundredths, 1, 2, is 36%. How's that? So this is one way. Fractions are always a little bit more trouble. We made the fraction into a decimal, 0.36. We made the 0.36, the decimal, into a percent. And so we really took 2 steps to get there. But here's, I think I showed you what I was thinking, or at least I was mentioning what I was thinking. $25 goes nicely into 100. Right? So 25 times 4 is 100. And if you recall what you have to do when you multiply this by 4, you better do this by 4. So 9 times 4 is 36. So 9 over 25 converted easily. Sometimes it won't, but this case it did, into 36 hundredths. And now I got it. This is 36%. Did you like it? Same
I
answer.
like that better.
I certainly did. Will it always work? Only when it goes neatly into 100. This one we did earlier, 4/5, does go nicely into 100 by multiplying by 20. And so I write it out, and then that would be 20 here. So 5 times 20 would be 100. Perfect. 4 times 20 would be 80. You like it? You like it? 80%. So not all of them do that, but there will be some that will. Is that okay? Now, there's a couple of weirdos, and you ready for the weirdos? If you, but you may know this, if you have a third as a fraction and you need to make it a percent, this answer is predictable, and either you know it by heart or you might as well learn it right now. If I start dividing and taking this into a percent, it's really 3 into 1, but I'm going to add a couple of zeros just to make sure. 3 into 10 goes, here's my decimal, 3. 3 times 3 is 9. 1 left over. You know what's going on here. 3 into 10 is 3. 3 times 3 is 9. 1 left over, and it's going to go on like that forever. So what I'm going to do is I'm going to make this a percent. I'm going to actually take the remainder and write it like this. And you'll see why. This is the decimal version. So 1/3 is 0.33 1/3. When I make it into a percent, it's 1, 2, 33 1/3%. And that's why I stopped after 2 decimal places. But this is easy enough to remember. 1/3 as a fraction is 33 1/3%. And so, frankly, if you had to do a computation with this, it would be easier to use the fraction than the decimal is not so hot. The fraction would be easier to compute. So this is one of the cases where the fraction would actually beat it. If they said take a 33 1/3% of some number, remembering that that really represents the fraction 1/3 would be your, would beat this by a mile. And the other one that's very, very similar to this is 2/3. And what it looks like is 0.66 2/3, which is 66 2/3%. These two are worth remembering, that a third becomes this and 2/3 becomes this. Because all the work to get there, it's easier. If you see it enough times, it will eventually click. And so this is, although they used to make people memorize a dozen of these, this one's actually worth it to save the time. And I think it's fairly easy to see from memory. Okay. All right, what do you think? In fact, one of the homework problems was this. Turn it into a fraction. Do you remember what it was? 66 2/3%, the fraction?
Just
What?
2/3.
Just 2/3. done. Okay. I'm not all for memorizing, but a few times it really pays out. I'm going to take a look. What we have next, let's see our time. What we have next, or what they call, this is 6.2. And they're calling it basic percent problems. These type of problems have been taught in all kinds of ways, and I've attempted over the years to teach them every which way you could imagine. And in the end, I like the way they're talking about first. And so here's the first problem. What is 15% of 60? Okay. This is a sentence. It's English. And what we want to do is change it to another language. And the other language is mathematics. So forget English. What we want is math. And I've been in so many classes in Maine, but also in Massachusetts, University of Massachusetts, where so many people were from somewhere else. And so English was not their first language, but honest to goodness, we could all understand the language of mathematics. And so everybody was good to go as soon as we wrote it down. And so this is what we want to do, get this out of English and into math. And so the word what is the part we don't know. And so the book uses N, you could use X, I don't care what letter you use. The word is equals. 15% has to be converted to either a fraction or a decimal. Now, if you're happier with decimals, we could easily make this a decimal. The percent would come off, we'd move it back, and it would be 0.15. The word of translates into multiply. And 60 is 60 no matter how you shake it. So you can put in that front 0, but I usually just throw that 0 in at the very end. But this is what we have to do. And it's pretty basic. Take 60, multiply it by 0.15. I'm just going to do it real fast. And that's 30. And that's 6. And that's 9. So I'm getting 900, but the decimal has to shift 1, 2 to do this computation. Okay. Now, I'm going to do one of each type. What percent of 42 is 21? What percent? Clearly, I need my answer as a percent, but I don't know what it is. And so I'm going to call that N. I usually use X, but I'm going to do N for a while. The word of is multiply. 42 is 42. Is equals. 21 is 21.
7.
Question. Did you have a question, Doris?
Yeah, would that be 7?
No.
Oh,
Remember then, this was multiply, and so I made a multiplication symbol. Sometimes
okay.
we would see 42 times n with a 42 first, but what I want to do is solve for n. I want to know what n is, not n times 42.
Oh, okay.
So in order to get rid of this 42 that's multiplied, the way they showed us to do it would be to divide this side by 42. But the minute you do that side by 42, you've got to come over here and divide this side by 42. Fair is fair. And so 42 divided by 42 is actually 1. And 1 times n, or n times 1, is just n. So here's my answer. But remember, it wanted to be a percent. Now, if you look, fractions for starters need to be reduced. And I'm hoping you'll see that 21 over 42 is just double. 42 is just double 21. Can you see that?
Oh, yeah.
Yes. So 21 into 21 is 1, and 21 into 42 is 2. So what I have for an answer is the fraction 1/2. But guess what? If you put that into your answer, they're not going to like it because they wanted it as a percent. So this is explaining why we have to go back and forth sometimes. I've got an answer, it's 1/2. But do you know this by heart without making a fuss?
5.
Better than 5.
50%.
50%. And if test scores will do it for you, if there was 2 questions and you had 1 correct, does somebody want to make up another analogy? But that's 50%, isn't it? Everybody go
Yes.
for 50%?
Yep.
Okay, all righty.
Mhm.
I got one more for you. There's 3 of them. 25 is 40% of what number? Okay, I'm gonna just abbreviate number. English, bad English. We want math, right? I'm kidding you. English is not bad. I just like math better. 25 is equals. 40% needs to be either a fraction or a decimal. I think the decimals in general are easier. 1, 2, so that would be 0.40 of multiply what number? I'm using n for a while. Can you see the translation? 25 is equals 40% into a workable number, either a decimal or a fraction, and of times, I use the parentheses, what number? I picked n, I could have picked x or any other letter you like. Because I want to know this, and it's multiplied to 0.40, I need to divide both sides by that 0.40, like it or not. The 0.40s hit the dust. The result is 1n, which is n. This is the answer, but I have to make it decent. This is a fraction including a decimal in it. I don't want that at all. So I'm dividing by 0.40, which is on the outside, into 25. If you recall, we didn't like decimals in the divisor, and so we would move this over, and I'm going to move it over 2 and move this over 2 and bring this up. So this 0.40 became a full 40. This, by multiplying actually by 100, this is the same thing. And so now I'm going to do this problem. 40 into 25 will not go, but 40 into 250 will. It's the same as 4 into 25. Let's go 6. 6 is 0. 6 times 4 is 24. I'm hoping this will eventually. 5, this is 10. And I'm going to bring down a 0. 40 into 100 is 2. 2 times 40 is 80. I'm going to subtract. And because I'm not done, I'm going to add one more 0 and bring it down. 40 into 200 is actually 5. 5 times 40 is 200. That is an exact answer. No remainder. So my answer is 62.5. I didn't want a percent. If you look back at the problem, it was just 40% of what number? And so I had the percent, I didn't want that. And so I could, this was a perfectly good answer right there. Now, here's what happened when they used to teach this. They used to tell you that there were 3 types of percent problems. In one case you multiplied, in the other case you divided, but people were never certain divide by what. And so they never could learn it properly. So if you were taught under that scenario, you never got it straight. Chances are good you didn't get it straight, because that was a lousy way to teach it. This, on the other hand, will work beautifully every time. And so this is one good way to do these simple percent problems. They call them basic percent problems. You write the sentence down, you translate it into an equation, is what it is, and you solve for the missing letter, whatever it takes. Okay? Any question about that? Was that going to work for you? And it doesn't matter how they write it. They could write it all kinds of which ways, but it won't matter because the way you go after it will be the same. We're going to get this out of English. 25%, I'm going to go 0.25 of, that's an of, by the way, is multiplied. What number, I'm going to go with X just to show I'm flexible, is equals 30. 30. You see the translation? When you want X, you want to get rid of this. You're multiplied to 0.25. So what you need to do is divide by 0.25 in both cases, or both sides rather. And so 25 divided by 25 is 1. 1x is x. And if you can just sort this out, you'll have your answer. Now you're dividing by 0.25. This is very similar to the last problem we did. The 0.25 is on the outside. 30 is on the inside. 1, 2, 1, 2. So this amounts to 25 into 3,000. 25 into 30 is 1. I'm going to subtract. I'm going to bring this down. 25 into 50 is 2. And there's no remainder. But the reason I brought this decimal up is there's one more division. 25 into 0 is 0. In other words, you have to take the division into the decimal point. And so the answer actually was 120. Okay. Now, could you have done this other ways? We have multiple ways now. This was what it was. One thing you can do is clear the decimal in this, and then it remains a fraction. If I multiplied this one by 100, which would be 2 decimal places to get 25, I would have to do the same to this. I would have to add a 2 decimal shift, which would take this to 3,000. This is the same thing that we ended up doing, isn't it? 3,000 divided by 25. This would have gotten you to your 120 if you continue to reduce it. So this required the long division. This, I guess they both required long division in a way. So what do you think? You think you can do some of these? How's our time?
Sure.
Yeah, honestly, I believe this, when you get all snarled up and you're not sure, decimal to percent is always a 2 decimal point shift. If you're going to the percent, it's 2 to the right. If you're coming back from the percent to the decimal, it's 2 to the left. Fractions, you may have to divide them out depending on the problem. But anyway, that's basically it. And so there's a lot of problems. I'm gonna tell you this quick story. So I was teaching percents long time ago. And so the student learned the percents, and they had been doing a lot of work on their house. And so they were working with a lumber yard that was giving him a certain percent off. What they realized, this was a really good story, they realized that the person that was giving the percentage off didn't know how to do it. And they were getting shortchanged. So they weren't getting what they had promised. So she realized how to do percents. She went to the person in charge and said, they've not been doing this right all along. And they were so embarrassed, of course. And they said, we'll fix it right away. Just don't tell anybody. Because they were doing them all wrong. They didn't know how to do percents. But see, she saved a lot of money because she knew how to do it. Right? And I've had that true. I've always had houses that needed work. And so I would be at the lumber yard. I would be at the paint store. And many times they thought I was a contractor because I came so often. So they give me a nice just percent. But you know what? I occasionally would try the math and make sure they knew what they were doing after that one person. It was hysterical. But yeah, it happens. So it's an important thing, you know, whether they're doing it right. So anyway, what do you say? So I think we can stop. I'm gonna definitely stop something. Let's see if I can do it. I know how to do this.